let's talk about some of those key tools in more detail. So you mentioned what are probably the big three in MLOps, I'm going to assume: Docker, Jenkins, and Kubernetes. So let's start with Docker and kind of explain to the listeners what Docker containers are and how they allow um, data science work to be easier to spin up and easier to replicate.
Yeah, absolutely. And it was really funny because I had written a blog post on it's called the why of virtual environments, containers, and VMs. Because I remember when I was first moving more into like the ML engineering and then ML ops role, I so I'd worked as a data scientist for a few years, and I had developed models in a Jupyter notebook. I spit out a pickle file, and I have no idea what to do with it. And more importantly, too, I was just kind of using tools and practices that I was either taught in like a boot, I was either taught in my boot camp or that I would pick up from people around me. And for example, a lot of times people would say like, "Oh, you're struggling. Go use Anaconda. Go use XYZ," but they would never help me understand the why of it. And so I like to think of Docker containers. So if we think about, and I have a bias towards Python, so that's just warning for, I guess,
No,
listeners,
you're
right?
doing production deployment, so that makes sense.
Ah, ha, 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 ha. All the R people are probably up in arms, going like, "How dare you?"
Yeah.
But if we look at, for example, we have a computer, right? That is, it could be a laptop, it could be a more server grade computer, but you have the hardware, you have all the applications, everything is on the OS. Lots of fun ways to screw it up. Um, but you have so much control, and also it's physically in front of you. We can kind of think of like a Docker container and virtual environments as representing kind of different layers of abstraction. So a virtual environment on, let's say for Python, it's kind of analogous to like a project folder. You have a language binary that sits in that folder. You import like whatever libraries you need, scikit-learn, all that.
Mhm.
It's all sits in there, and then you can kind of like switch in and out of it. And the idea is that you're not messing up your core like Python 2.7, right? That's running your laptop. Then you have we'll talk about a virtual machine, right? A virtual machine is just a step up from an actual physical computer. You have lots of options. For example, you can have multiple OSs going on it,
Mhm.
which means you can have multiple stacks of languages, of applications, of programs. Um, we go a step up above a VM, or step down actually, and you have a Docker container. A Docker container, it allows you to have that separation and encapsulation of the work that you're doing. You still share like an OS kernel, but essentially kind of it's just one more layer of abstraction. Where with a physical computer, you have the most amount of granularity, security, all that, as long as it's not connected to the internet.
Right.
Um, with a VM, you have a little bit like less control, a little bit less granularity, but
Right.
it's a lot more flexible. You have containers, which are even more flexible. They're a little bit more lighter weight. And then
Mhm.
you have virtual environments. And the fun part is you could have all of them on a single thing. So my physical computer can have a VM on it, which can then have multiple containers on it, which can then have multiple virtual environments on it. So it's not an either or, but it's that aspect of like thinking through the hierarchy of like what are your specific needs that you have, what are your security requirements, and how you adjust that. If you're a data scientist that is just trying out different projects, usually a virtual environment will be great. But if you're a data scientist that is seriously considering putting something to production, you'd want to use a container.
Docker
Um,
container, yeah.
and more than likely, for people who are like, well, about container versus a VM? Every time you launch a container to GCP or AWS, it's actually running on a VM. So in
Mhm.
this case, it's not an either or.
Right.
It's just some of that decision is being made for you as a data scientist.
Yeah, and I think Docker containers provide just the right level of abstraction for the vast majority of data scientist use cases because
Yeah.
it allows you often so you provide this Docker file that specifies exactly what operating system
Yeah.
and software dependencies will be available once that Docker container is running. And
Yep.
There are lots of pre-compiled Docker images, so you can, that, uh, yeah, that are very
Yep.
easy to download, that have exactly what you need, like have scikit-learn, have TensorFlow, and you know that everything is going to work together nicely. Um, and so, yeah, I highly recommend that if you're not using Docker containers already as a data scientist, that you explore that possibility, um, because it means that you can very easily replicate things because you're not changing. You don't necessarily need to change the library versions in that container. So you can have a particular data science experiment that you run on a particular set of data with specific versions of all the software libraries specified in that Docker file. Um, and then so you can come back to that a year later or 2 years later. And maybe even though in your local environment, you've changed and now you're using a much newer version of PyTorch and it would clash with the version that you were using a year ago or 2 years ago, it doesn't matter because that you had specified in the Docker container you were using for that experiment a year or two ago, this specific PyTorch version, and it's going to run just like it did in the past. So it makes it really easy to keep being able to run your code years later. And then something that you alluded to there, Mikiko, was security. Um, and this is another great thing about having these Docker containers is that they're separate from the rest of what you're doing on your system. So you can mess around in that Docker container and it's not going to ruin your whole computer.
Absolutely. Yeah, it was really meant to solve the it worked on my computer statement.
Right, exactly.
Yeah, absolutely. I think if you're a data scientist who is serious about developing applications and software, um, a cloud is a huge thing. Cloud is a huge thing, and having Docker containers, a lot of people I think concern themselves probably unnecessarily about vendor lock-in, especially if you're an individual practitioner. And containers give you that some of that flexibility in being able to play around with different cloud providers for sure.
Yeah. So you can, I mean, that's the other key piece here. Like I gave the analogy of wanting to be able to continue to use some data science code, some data science experiment that you'd written a year or two ago. But the much more common application, the analogy that I should have made, is that it allows you to pass your Docker container off to anybody in your organization or outside your organization, and then they can run your code exactly the way that you did. So thank you for making that point. Um, and so, all right, so that gives listeners an introduction to Docker containers if they weren't already familiar with them. Then what can we do with Kubernetes and Jenkins once we have those Docker containers?
Yeah, absolutely. So with Jenkins, right? Some of the other tools that are used in place of Jenkins include GitHub Actions, I think Circle CI, BuildKite. Essentially, like it's a CI/CD tool. So it's super super
Continuous.
important.
What is CI/CD?
Yeah. So CI/CD CD is continuous integration, continuous delivery, continuous deployment. It describes the practice of it describes a lot of things, but mainly it's the practice of automating code for continuous integration. It's building and testing applications and software. For continuous delivery, it's actually releasing the code to like a production server. And then for continuous deployment, it's actually deploying it either to like a server or deploying it to an audience. Rolling it out is also like rollout is also included in this continuous deployment. And this is a crucial component of MLOps practices because essentially, like, there's a couple reasons why. One reason, obviously, is like we don't want the data scientists to manually be doing something that can be automated. Um, for one
Right.
thing, it just makes their lives miserable. But more importantly, it exposes that process to, like fat fingered like issues.
Mhm.
So making mistakes, just for example, setting up the configuration, like typing in the wrong thing in the YAML file or whatever. Also too, like we need we do need tools like linting. We need to run robust test suites. uh, just because we want to make sure we're getting all the bugs before they get to production. And
Right.
it's also, you don't always have a QA person, and more importantly, the QA person, that's not their job isn't to find random bugs, but it's to be an essential partner in terms of thinking about, is the software doing what we intended to do? Is it working, not in the strictest sense of like, does the code run, but also, is it does it meet the kind of brand or the sort of audience that we want to meet? So yeah, so CI/CD, it's like an absolutely crucial part of MLOps and of any software, really.
Nice. So Jenkins is an automation tool that allows data scientists' processes to be automated in some way to allow for this CI CD to take place.
Yep, absolutely.
Cool. And then that leaves us with Kubernetes, which I think is more directly related to Docker containers themselves, right?
Yep, it's a container orchestration tool. So when Docker came out, and it's funny because I think Docker and Kubernetes, they were actually released. The first stable versions were released within the same year. I think people recognized pretty soon that if you have hundreds and millions of Docker containers, all with different ports, all accessing different resources, you need some kind of way to orchestrate it and to also kind of create pods, which are these like they are the individual subunits really within a Kubernetes cluster. We need to figure out a way to actually like scale up, scale down, allocate resources, all that good stuff. And that is also something that you typically don't want to do manually.
Right.
And these are amazing technologies. They had to really be developed by companies that were doing they were solving big challenges around big data, which ultimately set the stage for solving big challenges using models that require big data. So these are awesome tools.
And so I don't know the technical aspects nearly as well as you would, but I think the kind of general idea here is that when a data scientist has defined some machine learning program that can run inside a Docker container, or you could even have your entire web application running inside a Docker container, and maybe that web application happens to have some machine learning algorithms running in it. With Kubernetes, with this orchestration tool that you're describing, you can then have a system that is automatically responsive to the load. So, oh, we have more and more users logging in than we were expecting in our baseline assumption. You don't need to wake up and start up some servers and have manually set some Docker containers running on those servers. Kubernetes automatically gets those servers up and running, gets the Docker containers running on those servers, and all of a sudden, bam, your web application can handle 1,000 times or 1,000,000 times more people than you're anticipating when you went to bed.
Yeah, absolutely. Like it is a crucial component of that. Now, it's fun because the question of should data scientists know infrastructure like Kubernetes? Should they have to know how to set it up and how to run it? That is a very polarizing question like within the MLOps community because for a time there was this idea that a data scientist should have to know so much of this infrastructure piece. They should have to know the end to end, especially if they call themselves an ML engineer. And I remember when some key blog posts around that came out, and I thought about it, and I went, this is such an unreasonable expectation for data scientists. It's so we're asking them to be responsible for dealing with business partners, working with legal to ensure compliance. They're also now responsible for feature generation and engineering, model training, for making sure that their data sets are clean, making sure their models are performant, making sure they get deployed. And suddenly now they're also responsible for the infrastructure to develop that. When enterprise teams have full on teams of 5 to 20 people staffed to that.
Right.
So it's nice to see that the pendulum has swung back to no, data scientists should not have to ruin their lives focusing on a million things. Instead, it should be a collaboration, a partnership between different teams with different skills and experiences to deliver on the same thing. I'm very happy that the industry has, swung back to not trying to hurt people.